Good morning student, welcome to my class. So far we discuss what is kinematic relation and how can we apply kinematic relation for constant acceleration, and we already discussed graph theory and how to evaluate displacement time graph, velocity time graph, acceleration time graph and area under the curve. Clear? Now today we are going to start a new concept of physics, relative motion. And this relative motion is basically two-dimensional motion in plane, and in this case we have to study motion of an object with respect to another object, means we have to use here frame of reference. So what is frame of reference? Frame of reference is that place from where observer sitting at that place and the observer which study the motion of an object, that place is known as frame of reference. And there is two type of frame of reference. We will discuss inertial frame, non-inertial frame. So now let's start. Just I am remembering you what is frame of reference. Suppose there is a train and this train moving in this direction with velocity v, and there is two passenger inside a compartment. Suppose this is A and another one passenger who is sitting the same compartment which B, and suppose there is Mr. C who is sitting in the platform. This is platform of a station and this is C. Clear? Okay. Suppose time, this is AM. At a particular instant of time, if you ask to A what is the velocity of B while they are moving with a moving train with certain velocity, so A will give answer that is B is at rest, because A observe B which is at rest and B also observe A at that time, A also rest, means these are moving with a, these are inside a moving frame, whereas A observe B is at rest and B observe A is at rest, because they are moving inside a moving train. Clear? So we can say here the velocity of A minus velocity of B equal to 0. There is no velocity inside this reference frame. But at the same time, instant of time, if it will observe C to A and C to B in motion condition, at the time 10 am, A observe B rest condition, B observe to A rest condition, but same instant of time, C observe both A and B which are moving with certain velocity, because in this case A and B both are in a frame of reference and that frame is known as moving frame, or you can say compartment of a train, or this is moving frame or moving frame of reference. But observer C, the Mr. C who is sitting inside the platform of a train and that platform which is rest condition. So motion of an object depends on frame of reference. Clear? We already discussed there is nothing absolute rest and absolute motion only when the relative rest and relative motion is possible. Like this 10 am, A observe B rest, B observe A rest, but C observe both are moving at the same time interval. So relative motion is possible, absolute motion and absolute rest is not possible. Clear? Now we will discuss this relation here. Okay, we already discussed what is motions parameter. Motions parameter means we have two type, there are three type of motions parameter. First important, that is displacement, second one velocity, and third one that is acceleration. These are known as motions parameter. Clear? So we will discuss here relative motion, means relative displacement, relative acceleration and relative velocity. So suppose in two-dimensional motion, this case x axis and here this axis y, suppose at any instant of time t, a body situated at point A with position vector r1, or you can write position vector ra. Similarly, after certain time it changes its position to point B with a position vector r2, simply rb. Clear? So in this case if I want to find, this is displacement vector Suppose displacement vector in this direction you can take, and this displacement vector can be write, that is delta r vector, suppose, and this delta r vector can be write by using triangle law of vector addition. These two vectors are equal direction, this is opposite direction, and this vector can be write delta r equal to rb vector minus ra vector. And in relative motion case, we can write this term which is equal to RBA. Clear? It means that, or simply RBA equal to RB minus RA. Means, first we have to find relative position, means position of B. Position of B with respect to A. Clear? This is known as position of B with respect to A. Clear? If observer is situated at this point, if observer here, then it observe the position of B, it means that. Clear? It means position of B with respect to A. जदि आम ए रे ऑब्जर्वर को रखिबा ताले ए बी रो पोजीशन को ऑब्जर्व कर, दिस इज नॉट relative displacement, you can say. Clear? Okay. And you can write another one format also. Suppose RAB, it means that position of A minus position of B. So in this case, observer situated at B, this is position of observer, and this is frame of reference, you can say. So position of A with respect to B, we can write this way. Clear? This is known as relative position. Now if you want to find relative velocity, then this is relative position. Relative position. So relative velocity, how can we find? If we differentiate this relation with respect to time, then we can write d by dt of here RAB, which equal d by dt of RA vector minus d RB by dt, and this is known as velocity, the rate of change of displacement with respect to time. We can write velocity, that is VAB, which equal here similarly VA minus VB. This velocity is known as relative velocity. Why? Because absolute motion, absolute rest is not possible. Always motions in possible in the relative format. So this is relative velocity of A with respect to B. Means B respect re A ro velocity ta kete. Clear? This is known as velocity of A with respect to B. B respect re A ro velocity ta kete. That is known as the relative velocity. And you have to remember one thing here. B means this is the position of observer. Position of observer. A means velocity of A. This is velocity of A. A ro velocity को B observe करियो, means B position रे observer अछि and it observe the velocity of A. This is known as relative velocity of A with respect to B. Clear? So if you want to write the definition of relative velocity, so relative velocity of one object with respect to other or another, with respect to another can be write, that is VAB equal to VA minus VB, when both are in motion condition. Clear? Okay. Next, how can we understand this relation? So how can we use this relation? Suppose there is a body A on the ground, and you have to first choose what is frame of reference here. This is frame of reference, means ground frame, because the body which moving on the ground frame with velocity VA, and another body is here B and this body which is moving velocity Vb also on the ground frame. So in this case, how can we find velocity? How can we find relative velocity in this case? Suppose I am writing here relative velocity of A with respect to B. It means that A ro velocity da B kete dekhibo. Means first we have to find here the frame of reference or observation point. यदि आम बी रु ऑब्जर्व करवा ताले ए रो वेलोसिटी बी को केते देखा जो. इट मीन्स दैट द वेलोसिटी ऑफ ए इफ वी ऑब्जर्व फ्रॉम द बॉडी बी. क्लियर. सो इन दिस केस आम ये फास्ट कौन करवा, वी हैव टू एज्यूम if we observe from this point, then we have to assume this velocity Vb which is at rest condition. This is at rest condition. क्लियर. ऑब्जर्वर जो फ्रेम ऑफ रेफरेंस रे बसिबो, ऑब्जर्वर जो मूविंग ऑब्जेक्ट रे बस पड़िबो ताको हमें रेस्ट मानि नेबा. क्लियर. हम एति तो मन रख, हमें जो फ्रेम ऑफ रेफरेंस रु ऑब्जर्व करिबा से फ्रेम ऑफ रेफरेंस सब बेले रेस्ट कंडीशन निया जाय. इफ वी ऑब्जर्व फ्रॉम रेफरेंस फ्रेम बी, देन वी हैव टू एज्यूम दैट दिस फ्रेम and this system is at rest condition. Now we have to observe from here to motion of A, and this relation can be write VA vector minus VB vector. माने B को हमको कोडी रेस्ट करिया पड़िबो, जोडी ऑब्जर्वर थिबो से फ्रेम को हमको रेस्ट करिया पड़िबो. सपोज one example, suppose you are moving from Berhampur to Bhubaneswar, BAM to Bhubaneswar. Here this distance BBSR with certain velocity. Clear. By a train. तमें बरहमपुर टू भुवनेश्वर बाहर ट्रेन रे. देन सपोज तमें बरहमपुर बाहर 7:0 और 4 PM. तमें 4टा बेले बरहमपुर भुवनेश्वर बाहर एका ट्रेन रे जाऊज. तुम कंपार्टमेंट तुम जो कंपार्टमेंट रे अच्छ, तुम फ्रंट रे आउ जने मिस्टर बी अच्छा, तुम मिस्टर ए और मिस्टर बी अच्छा. क्लियर. तुम सिंगल तुम एका ही कौड़ी आज भुवनेश्वर जाऊज. क्लियर. सपोज भुवनेश्वर ट्रेन पहुँचार थिला सपोज 9 PM एट नाइट, राति 9टार भुवनेश्वर पहुँचार थिला. क्लियर. ओके. तुम बरहमपुर क्रॉस कला बेले मिडवे बिटवीन बरहमपुर टू भुवनेश्वर, सपोज ट्रेन को रास्ता रे भी रही जाए. क्लियर. एंड एट दैट टाइम तुम से टाइम शोई पड़, तुमको निद हो जाए, तुम जस्ट उठी पड़ा पर तुम देखा सबुआड़े अंधार होगी अच्छी. तुम फ्रंट जड़े बस, तुम कौन क्वेश्चन पचार, तुम क्वेश्चन पचार भाई सर भुवनेश्वर आसीगला कि. थिंक अबाउट इट. सर भुवनेश्वर आसीगला कि यार मीनिंग कौन. जमी भुवनेश्वरटा तुम पाक चलिकी पलि आसुची आ तुम जो फ्रेम रे अच्छ से फ्रेमटा रेस्ट हो जाए. मीन्स भुवनेश्वर मूविंग टुवर्ड्स यू बट योर फ्रेम इज एट रेस्ट कंडीशन. एक्चुअली ऑब्जर्वर ए पॉइंट रे किए ये ऑब्जर्वर तुम निजे तुम ऑब्जर्व कर भुवनेश्वर को, भुवनेश्वर तुम पाक पलि जाऊँ कि भुवनेश्वर तुम पाक चलिकी आस. एक्चुअली किए चलिकी जाऊँ, एक्चुअली तुम ट्रेन भुवनेश्वर मूविंग रे जाऊँ. ट्रेन व्हिच आर मूविंग टुवर्ड्स भुवनेश्वर, तुम ट्रेन भुवनेश्वर आड़े जाऊँगी बट भुवनेश्वर रेस्ट अच्छी, किंतु तुम जो फ्रेम रे अच्छ से फ्रेम को कह जाए ऑब्जर्वेशन फ्रेम, आउ से फ्रेम को सब बेले रेस्ट कंडीशन में निया जाए. Clear. This is known as frame of reference. So velocity of A with respect to B means B आडू आम देखा जो फ्रेम रू देखा से फ्रेम को आम फास्ट कौन ना रेस्ट मानि ना. क्लियर. सो बाय यूजिंग दिस कॉन्सेप्ट वी कैन सॉल्व डिफरेंट टाइप ऑफ प्रॉब्लम. क्लियर. ओके. सो the graphical representation of relative velocity we can draw here. Suppose there is two vector A and here velocity suppose VA and one body which moving this direction with velocity VA, another vector B, its velocity VB and angle between them theta. Now we have to find here velocity of A with respect to B. जदि आम बी रु देखा ए वेलोसिटी केते ताले बी रु देखा मीन्स आम बी को फास्ट रेस्ट करिया और बी वेक्टर को रेस्ट करिया. ताले बी वेक्टर आम केमिति रेस्ट करिया, बिकॉज दिस इज ए वेक्टर. सपोज दिस इज वेक्टर 5 Newton दिस डायरेक्शन. नाउ वी हैव टू मेक दिस वेक्टर मीन्स 0 वेक्टर एक आम जीरो वेक्टर करार अच्छे मीन्स वी हैव टू मेक अनदर वन वेक्टर लाइक दिस बोथ मैग्नीट्यूड आर इक्वल बट डायरेक्शन अपोजिट होगा दरकार देन टोटल वेक्टर विल बी जीरो इन दिस केस क्लियर सो सिमिलरली इफ वी ऑब्जर्व फ्रॉम पॉइंट बी तो बी पॉइंट को फास्ट आमको रेस्ट करार अच्छे क्लियर और बी रो वेलोसिटी को फास्ट वी हैव टू मेक इट रेस्ट or we have to make this velocity will be 0. So how can we make this velocity is 0? So in this case we have to make another negative vector here. If we place another negative vector here, that is minus vb vector, then minus b plus b equal to 0. That means vector can be shift by or without changing its magnitude or direction. So if we displace this vector here, then this vector will be like this and this vector can be write minus vb vector, and there is two vector now, vector a and minus b vector. Angle between two vector is 180 degree minus theta. Now use parallelogram law vector addition. This vector is known as resultant vector, and this vector can be write velocity of a with respect to b. हमें b रू observe करिया v को यानी कितना है वो by using parallelogram law of vector addition we already know that is velocity of a vector plus minus velocity of b vector, and this is equal to a vector b vector equal va vector minus v vector. So this is the general expression for relative velocity. Clear? So velocity of a with respect to b, velocity of a with respect to b equal to va minus vb, and va means this is ground frame, vb means this is also observation in ground frame. Clear? So frame of reference is important here. If you want to find magnitude of this vector ab, so how can we find magnitude? That is va square plus vb square plus 2 va vb cos 180 degree minus theta and square root. Then we can write va square plus vb square minus 2va vb cos theta. Why? Because 180 minus theta is second quadrant, and second quadrant only sine function positive and cos function negative. This is general formula. This is the magnitude of relative velocity. Clear? If you want to find direction, this is direction means this is the angle between resultant or relative velocity of a and b with respect to a. So in this case we can write this is tan this angle, this total angle, suppose this angle I am taking here phi. Phi indicate the direction of resultant vector or relative vector. So phi equal to, we already have relation b sin theta by a plus b cos theta. So b is here. So b sin theta means vb sin theta 180 degree minus theta divided by a plus b cos theta. A is your va. So va plus vb b sin theta by a plus b cos theta cos 180 degree minus theta. So in this way you can find the direction of resultant vector. If you take the special case of this relation, suppose theta is here 0 degree means two body velocity a and velocity b which are moving along same direction. So theta 90 degree, so in this theta 0 degree. So velocity of a with respect to b respect माने b के यदि हमें ऑब्जर्वर को रखिले ये कितना देखियो a रा velocity. Clear? This is known as relative velocity of a with respect to b. So in this case we can write that is va minus vb. Clear? This is simple formula we have to use here. VAB equal to magnitude. If you want to find magnitude, then magnitude of this vector can be write magnitude of VAB which equal then a square plus a VA square VB square minus 2AB cos theta, because theta is 0 degree here. So cos 0 which is equal to 1, then VA square plus VB square minus 2 VA VB. So in this case we can write VA square plus VB square minus 2 VA VB under root, and this is a minus b whole square and square root cancel, then VA minus VB is final answer. This is known as relative velocity. So we conclude from this relation, if two bodies are moving along same direction, then their magnitude will be difference, and difference VA minus VB is our relative velocity. Clear? Like example, suppose one body is here which moving with 20 meter per second and another object here which moving with 10 meter per second on the ground frame. Suppose this object A and this object B is here. Find velocity of A with respect to B. So in this case, we can write VA minus VB equal velocity of A. First, this is origin, this direction is positive and this is negative direction. So because these are moving towards this direction or towards east direction, then it will be positive. So VA velocity 20 minus 10 equal to how much? That is 10 meter per second. It means that velocity of A with respect to B means observer is at B position. Clear? So if you observe the velocity of A with respect to B means observer situated at point B, then it observe the velocity of A and it observe that the body A which moving towards this observer with velocity 10 meter per second. Clear? This is not relative velocity. If observer situated at this point, that means VBA, A means observer situated at point A and it observe that velocity of B minus velocity of A. So in this case VB is 10, VA is 20 and final answer minus 10 meter per second. It means that if observer placed at A, then it observe the velocity of B, and in this case observer observe that the body which moving minus 10 means this body which moving this direction. Clear? A बर्तमान observe कला कौन ना बॉडी B पछकु पछकु -10 मीटर पर सेकेंड रे पछकु पछकु आसुची. क्लियर? व्हाई? बिकॉज से निजे 20 मीटर पर सेकेंड रे चलची बट ये 10 मीटर पर सेकेंड रे चलची बट जो क्वेश्चन के हमें ऑब्जर्वर नहीं जीवा ता वेलोसिटी 0 हो जाए. 0 केतले हबो ना जदि यार वेलोसिटी या ऊपर अपोजिट रे हमें लगै द. ए भी आउट ऑफ डेफिनेशन तुम कहि पारो. जदि यार वेलोसिटी या ऊपर अपोजिट रे लगै देबा ताले -10 आंसर पळे आसो. सो ऑब्जर्व A to the velocity of B which is equal to -10 meter per second. This is known as relative velocity. And if we take next case, suppose theta is here 180 degree means two bodies are moving opposite to each other means this direction. Suppose VA and this is VB. So in this case, so VAB its magnitude will be how much? A square plus B square plus A square plus B square minus 2AB cos theta. Theta is 180, then cos 180 minus 1 minus minus plus A square plus B square plus 2AB means VA plus VB whole square which equal to VA plus VB simply. So the relative velocity of two objects which are moving opposite to each other at that time simply we have to add their velocity. This is velocity means suppose one object moving this direction with 10 meter per second A and another object moving this direction suppose 20 meter per second. Clear? Okay, so here we have to find velocity of A with respect to B means observer situated at point B. So this is the rest condition. Clear? Then we can write VA minus VB equal to VA velocity of what opposite direction means negative axis, so we have to use here -10 minus velocity of B that is 20, so here 20, then answer will be -30 meter per second. This negative sign indicate that if observer situated at B, sorry this is B, if observer is placed at point B and he observe the motion of A, then it will find that is -30 meter per second means A object which moving this direction with a speed of 30 meter per second. B को एबे लागिबो A रो स्पीड -30 meter per second means ये तो ए पाखे चल जी ये पछुको एमती 30 meter per second रे पछुको चल जी. This is known as relative velocity. Clear? So by using this formula and concept you can solve the numerical based on relative velocity. Clear? And frame of reference is important here. Now let us take one more example regarding frame of reference. So suppose this is ground frame and Mr. A which moving with 10 meter per second, clear? And here suppose there is a truck and this truck which moving with, suppose this truck is moving with 5 meter per second, clear? Okay, and there is another one body, or this is Mr. B which moving on the truck with a speed of 2 meter per second, suppose this direction, clear? So now we have to find here, but this 5 meter per second because truck which moving on ground, so ground respect रे truck speed केते, suppose this is t and this is with respect to ground respect से 5 meter per second अच्छी. And similarly here Mr. A moving 10 meter per second means on ground frame, ground ऊपर 10 meter per second चलची, but observer B which moving 2 meter per second on the truck, this is known as with respect to, we can write here with respect to truck. The velocity of B is 2 meter per second with respect to truck ऊपर 2 meter per second से आकुआ को चलची, clear? So frame of reference is important. Now we have to find velocity of A with respect to B, means velocity of A minus velocity of B, clear? So we can write here, we have to always write in ground frame, means velocity of A co frame by we have to always use in ground frame, this is also in ground frame. You have to solve the numerical in relative velocity problem always in ground frame. So बोले ground frame रे problem को solve करिया पाई try करो, so बोले easy हबो. Then velocity of A with respect to ground, here given velocity of A with respect to ground, that is 10 meter per second because this is positive direction, minus BG velocity of body B with respect to ground, but given here velocity of body B with respect to truck. So first we have to find velocity of body B with respect to ground. So how can we find this velocity? Now we already have which relation, that is velocity of B with respect to truck, how much, that is 2 meter per second, this is given. 2 meter per second means velocity of B with respect to truck. So we can write here velocity of B minus velocity of T by using relative velocity formula, but we have to use your ground frame, this is ground frame and this is also ground frame which is equal to 2. But we need velocity of body B with respect to ground. So velocity of body B with respect to ground which equal 2 plus velocity of truck with respect to ground, and it is given velocity of truck with respect to ground 5 meter per second, then 2 plus 5, that is 7 meter per second velocity of B with respect to ground, clear? Now use this formula here, then 10 minus this is 7, that is plus 3 meter per second. It means that velocity of A with respect to B means observer is at point B and he observed that the velocity of A बुझा पड़ला, ट्रक ऊपर जो ऑब्जर्वर अच्छी बर्तमान ट्रक ऊपर थाई कि से ए रो स्पीड को, ये दौड़ दौड़ के जाऊँ रास्ता रे ए रो स्पीड को से ऑब्जर्व को कौन जना पड़ुची ना ए रो स्पीड टा ऑब्जर्वर को लागुची केते ना 3 मीटर पर सेकंड से ता पाकु आसे, बुझा पड़ला? That means observer B observed that the velocity, the body A or Mr. A which moving towards observer with a speed of 3 meter per second, clear? You can change this question. Suppose I am taking here velocity of A or velocity of B with respect to A. If observer situated at A, ताले A जो दे में observer नेबा A B को कितना speed रे देखुची. So in this case we have to find here velocity of B minus velocity of A which equal, we have to solve always in ground frame and G and G. Then velocity of BG which equal to BG means 7 meter per second minus AG velocity of A with respect to ground means 10 is here. So how much? That is minus 3 meter per second. It means that if observer situated at A, the observer ame A को नहीं जीवा, ताले observer now see the velocity of B ट्रक ऊपर मोशन रे अछि. At that time it observed that this is -3 meter per second means B body ए पाहाकू पछकू पछू केते स्पीड रे आसी -3 मीटर पर सेकेंड याको ऑब्जर्व हबो दिस इज नोन एज रिलेटिव वेलोसिटी क्लियर सो बाय यूजिंग दिस कांसेप्ट you can solve different type of problem. So let's take another one example. This is ground frame and suppose this is police and here I am taking thief. Clear? Okay. So the initial separation between police and thief, this is police P and thief you can take T. Initial separation suppose here that is 100 meter. Clear? And here acceleration of police suppose 0 and here the acceleration of T thief also 0 means they are moving with constant velocity. Suppose its initial velocity up equal how much? Suppose here 70 meter per second and suppose its initial velocity take that is ut suppose 20 meter per second. Clear? Then my question is that find the time, find the position and time such that police will be catches the thief. So we have to find the time where they will meet and what distance from this thief to they will meet each other. Clear? Police thief को दौड़ुचे केते स्पीड रे ना 70 मीटर पर सेकंड रे and thief which is moving with 20 मीटर पर सेकंड केते टाइम परे पुलिस thief को धरिबो और केते डिस्टेंस से धरिबो we have to find here. Clear? So by using relative velocity concept it will be easy to find this relation. So now come to solution part. So in this case acceleration of police equal to 0. This is for police speed and initial velocity of police that is 70 meter per second means this is for ground with respect to ground, this is also with respect to ground frame of reference. Clear? And this is acceleration of thief equal to 0 and initial velocity of thief equal to 20 meter per second. First we have to find here relative velocity. So relative velocity of police with respect to thief pt which is equal to up minus ut and up is given 70 minus 20 equal to 50 meter per second means if observer situated at B, if observer situated at this point then it observe that the police which moving towards this observer with a speed of 50 meter per second. This is not relative velocity. So here relative acceleration of pt which is equal to 0 because here 0 and this is also 0 and next relative displacement, this is initial displacement, relative displacement p and t. Now this is 100 meter. Clear? Now we have to find time taken to meet each other or what is the time for which police catch the thief. Clear? So in this case we have to find this is initial velocity, this is acceleration, then this is displacement. So we have to use relation s equal to ut plus half at square. Clear? So throughout the motion acceleration is constant. So here this is 100 which equal to ut means we have to always use here relative displacement, relative speed, relative acceleration. So ut means this ut which is 50 meter per second. So 50 into time t plus 0 because acceleration is 0 here. So time t equal to 2 seconds. So after 2 seconds police will catch the thief. 2 सेकेंड परे पुलिस thief को और चोर को से धरि परिबो केते डिस्टेंस रे सपोज at the time because both are moving with constant velocity. So this is initial position, and this is initial position of thief, and this is initial position of police, and separation between them 100 meter. After time t, means this t move this point and p also move this point, because they meet each other at this point, and it will time take t, which is equal to 2 seconds. So at that time the distance covered by the thief and this distance is x. Clear? So for x or thief, x equal to ut plus half at square. Clear? Initial velocity of thief how much? That is 20 meter per second. So you have to use your 20 into time, because in 2 time this will move this distance. So you have to use 2 plus 1 by 2. This is acceleration 0, because at is 0, which is equal to t square. Clear? Then that is 40 meter. Clear? So thief travel a distance which is 40 meter. If thief travel 40 meter, then police has to travel 40 plus this is 100. So total distance covered by police how much? It will be 140 meter. Clear? Now solve by this numerical method. So for police, suppose x equal to ut plus half at square, and u is here how much? That is 70. So 70 into 2 seconds, that is 140 meter. Clear? So they will meet at this point. It will take time 2 seconds, and at that time the thief travel a distance of 40 meter and police has to travel a distance 140 meter. Clear? This is relative velocity. So by using this concept you can solve different type of problem. Clear? Okay. So now let's start. This is relative velocity in one dimensional motion. And you can solve for two dimensional motion of relative velocity, that is known as Riemann problem. Riemann problems. So Riemann problem means, suppose I am discussing here case 1. So this is the direction of rain which is falling vertical downward direction, and suppose this is VR, velocity of rain, and this is ground level, and there is observer or man which standing on the ground, and its velocity suppose 0. So at that time we have to find the direction of umbrella. What is the direction of umbrellas held by the observer, such that he can protect himself from the rain? So he has to hold umbrella like this. If he hold umbrella like this direction, then he can protect the rain from himself. Clear? This is first case. If second case is important, suppose this is the direction of rain like this, and suppose the velocity of rain which is moving downward direction, and it is suppose 50 km per hour. Clear? And this is ground level, and one person moving this direction with a speed of, suppose I am taking here, that is 40 km per hour. Clear? Now question arise here. Find the direction of umbrella, hold umbrella sword hold by man, so that he can protect himself from rain. Clear? को डायरेक्शन रे से अम्ब्रेला धरिले से जो वर्षा आमर रेन ड्रॉप आसी, रेन ड्रॉप से निज को निजे प्रोटेक्ट हो पारिबो. मीन्स वी हैव टू फाइंड हियर द डायरेक्शन ऑफ रेन ड्रॉप. सो इन दिस केस come to solution part. So in this case, first we have to use your vector format, and this is observer. You have to always choose in Riemann problem observer is man. Clear? So velocity of rain with respect to man. So we have to write here velocity of rain minus velocity of man. So first we have to find velocity of rain. So here velocity of rain, this is downward direction. So first we have to use vector format. This is x-axis minus x, y, this is minus y. Here I cap, here j cap, but here minus I cap, this is minus j cap. Clear? Vector format is easy to solve. So this is the direction of rain which falling downward with a speed of 50 km per hour. So we can write velocity of rain, because this is downward direction means negative sign. So you can write here that is minus 50 j cap. Similarly, the man which moving towards this direction means x-axis. So you can write velocity of man with respect to ground. This is also with respect to ground, and this is also with respect to ground. So here 40 and moving towards x-axis, positive x-axis, this is I cap. Now use this relation here, then we can write velocity of rain with respect to man can be write how much? VR is minus 50 j cap minus Vm is 40, it is 40 I cap. So this is the vector form of relative velocity of rain with respect to man. Clear? So next you have to draw the coordinate system like this. Now represent 50 minus j cap means this direction 50. Clear? 50 j cap downward direction, minus 40 means this direction, so 40 I cap. Now complete parallelogram and it will give the resultant velocity of rain with respect to man. Clear? And you can also calculate its magnitude, then its magnitude will be velocity of rain with respect to man equal, that is a square plus b square, because angle between them is 90 degrees. So a square plus b square plus 2ab cos theta cos 90 0. So you can write here that is 40 square plus 50 square under root, which equal to 1600 plus 2500 root over, and then it will be how much? That is 00 651 213, that is 41, or which equal to how much? That is 1041 root 2 kilometer per hour. That means this is the final velocity observed by person which are moving on the ground with 40 km per hour. जे 40 km per hour रे आकुआ को चलजी सेही टाइम रे देखो रेन रो स्पीड ता केते जना पड़ुची 10 root 2 41 km per hour, and this is direction. So he has to hold umbrella in this direction. जब से umbrella ए डायरेक्शन रे होल्ड करे, ए डायरेक्शन से umbrella धरे, then he can protect himself from the rain. Clear? This is the direction of umbrella. Why? Because this is the direction of relative velocity. So question may ask find the angle, vertical angle, this angle suppose theta and this angle also theta, and this is perpendicular 90 degree. By using tan theta here, then tan theta equal to perpendicular upon base. Only you have to use magnitude here. So perpendicular upon base, perpendicular is 40. So here 40 divided by 50. Then how much? That is 4 by 5. And this is triangle, you have to remember. Suppose this is here, this is 4, this is this is 3, and this is 5, and this angle will be 53 degree. Then tan theta 4 by 5, you have to write this way. So tan inverse how much? It is 4 by 5 degree. Clear? This is the direction of rain. So by using this concept you can solve. So this is the direction. If this direction the man hold umbrella, then he can protect himself from the rain. Clear? Okay. Next come to another one case. Suppose rain falling downward with certain angle, and suppose this angle is 37 degree. This is the direction of rain. Clear? And velocity is here also 50 km per hour. Clear? And this is a ground frame. This is also with respect to ground. And a person or cyclist you can say which moving this direction with a velocity of suppose 20 kilometer per hour. Unit should be equal. Clear? So find the relative velocity of rain with respect to man. This is man and this is rain. So in this case we have to find here velocity of rain with respect to man means Vr minus Vm. So first we have to find what is Vr, velocity of rain, because it falling downward with certain angle, vertical angle 37 degree. So we already know how to resolve a vector into its rectangular component. Then its component along this direction, how much? Then it will be 50 into cos theta, cos 37 degree. And how much? That is 50 into cos 37, 4 by 5. Then 5 10, that is 40. This direction, raindrop falling with a speed of 40 kilometer per hour. Clear? And this component will be how much? That is 50 into sin 37 degree and 50 into sin 37, 3 by 5, 5 10, that is 30 kilometer per hour. That means this is x-axis, we can write 30 I cap, and this is downward direction 40 and 40. So resultant vector will be like this. So velocity of rain we can write how much? 30 I cap minus, this is 40 downward direction, so minus 40 j cap in vector form. Clear? So first we have to write here Vr, then again find Vm. So velocity of man, because man moving this direction with suppose this is x-axis, so in this case we can write here 20 I cap. Clear? Now use this value here. R means here 30 I cap minus 40 j cap, negative sign, velocity of man 20 I cap. So if you solve 20 I cap minus 20, sorry 30 I cap minus 20, then 10 I cap minus how much? That is 40 j cap. Clear? So this is the direction of this is resultant velocity of rain with respect to man. Clear? So in this case, this is resultant Vr equal to how much? That is 30 I cap minus 40 j cap. Okay, 30 I cap minus 40 j cap minus V. This is 20. Okay, then 30 minus 20 equal to 10 minus 40. Okay, now use vector sign here. Then in this case, this is 10 I cap, this direction 10 I cap minus 40 j cap and 40 j cap here. Clear? And this is the resultant vector, this direction, velocity of rain with respect to man. Clear? And so in this case, man has to hold umbrella this direction so that he can protect himself from the rain. Clear? And suppose this angle phi, then how can we find? Tan phi equal to perpendicular upon base, and this is perpendicular, this is base, perpendicular is 40 here, so 40 by 40 divided by 1, then phi will be, that is tan inverse how much? 4 by 1, sorry, this is 10 4 by 1, this is final answer. Clear? So this angle means this angle is here, this angle is how much? Tan inverse 4 by 1. So if the man hold his umbrella in this direction, then he can protect himself from the rain. Clear? So dear student, by using this concept you can solve different type of problems. So first thing is that you have to remember which is observer, and observer frame always is at rest position. Clear? So this is rainman problem, question may ask like this, so you have to remember step by step, and by using this concept you can solve relative velocity problem. Clear? Thank you all.